If you would recall, last time we talked about Leach's rules for addition. These aren't really just mine. I call them Leach's rules because that's me, and I get to name things after myself. So I call this Leach's rules for addition. And the idea is that we only add things that are the same, and when we add them, it doesn't change what they are. This is how we understand addition intuitively, but I want to say it explicitly. I want to say explicitly what we mean when we say we're adding things up. And this defines what we can add up and what happens when we add them up. Now, this is definitely how we want things to work, because if I have 1 pen and I add 2 pens, I have 3 pens. The 1 plus the 2 equals 3 was 1 pen plus 2 pens is 3 pens. They're still pens when I add them together. I wouldn't want to say take 1 pen and then put 2 pens on the piece of paper, and then all of a sudden 3 marbles show up. That would be horrible. That would be when we add things, it changes what they are. But that doesn't happen. We only add things that are the same, and when we add them, it doesn't change what they are. That's the core operation of addition. Then we have to just identify sameness in different contexts, and we've seen some on the quizzes. One of them, and the reason that I wanted you to write out what you were doing in the addition quiz, one of the samenesses that we've added is place value. So place value. When we add numbers up, like 53 and 14, we line up the ones with the ones, then the tens with the tens, and we add those up. Ones with ones. And tens with tens. That's what sameness is when we're just adding up numbers like this. Tens with tens. So just understanding place value and addition fits into the concept of sameness. Here where the sameness is place value. We also saw sameness in common denominators. When we add fractions, sameness in fractions is the denominator. The denominator is the denomination of this fraction, and they have to have the same denomination so we can add them. So that is sameness in fractions. And when we add them, so we can add these because they are the same. They have a common denominator. That's sameness in fractions. And when we add them, it doesn't change what they are. So since we're looking at the 11 denominator as what's making these the same, when we add them, it doesn't change what they are. 5 of these things plus 3 of these things is 8 of those things. Other places we see this, especially in an algebra class, so these are both x terms. So some of you knew the words, which was awesome. These are called like terms. Like terms actually means 2 things. So some of you that at 6 out of 7 on that quiz can go back and fix this part of it. Like terms means 2 things. It's the same variables with the same exponents. I'm being excessive when I'm asking you to do both of those things. But it's really important that we don't just look at these as x terms, but that we also distinguish these from x, say, x squared terms. So like terms means the same variables with the same powers. So like terms means the same variables with the same exponents. So what that means is that 5x and 3x squared are not like terms. They have the same variables, x's, but those variables don't have the same exponents. One's an x to the first, the other one is an x squared. So that makes them different, not like terms. So x and x squared, those are different. Now, that's not a new thing that I just said. This is something that we did right up in here in place value. We keep the ones separate from the tens, just like we keep the tens separate from the hundreds. So when we build a polynomial like this, it's just like looking at a number where the x would be the 50 and the x squared is like 100. So this would be 300. So these are not like terms. We wouldn't add them. They would show up in different columns if we were to add them up. So they're very similar to the place value thing. So this is very similar to place value. And some of you also identified not like terms with the other one where I asked you what 5x plus 3y is. So 5x plus 3y, also not like terms. One's an x term and one is a y term. We wouldn't want to add those together. We don't have 8 of anything in that case. The other one we saw, let's see, the other one we had was, say, dollars. If I have $5 and you find $3, then you have $8. And being students, someone immediately asks you for that $8. They're like, oh, give me that $8. So $5 plus $3, we can add these because they are the same. They're the same denomination. They're the same currency. And so when we add them together, it's still $8. It doesn't change what they are. We would not want to live in a world where we take $5, add $3, and all of a sudden we have 8 pens. Oh, no, I need to have $8. I don't need to have 8 pens. We can't change what they are just because we add things together. That would be crazy. And then similar to this, if we change one of the types of currency, when we had $5, and 3, I think it's like this. Do you go like this? €3. This is not 8 of anything. So we don't have the 5 plus 3 doesn't mean anything in this context. Now, some of you did point out, if I have $5 coins and 3 1 euro coins, we could have 8 coins. And that was very good. I like that one. That was a nice little turnaround. You turn that one around on me. So, but as it stands, $5 plus 3 euro, we wouldn't have 8 of any currency. Any questions? On the sameness quiz, you did not have to show your work with pictures. You just type in what the answer is and then type in what's the sameness in that one, or what's the not sameness. So also what a lot of you pointed out, and you kind of had to do this on the sameness quiz, is that I asked you to add some things that we couldn't add where we're just adding the 5 and the 3. We had to change things around. So on the same quiz, I said, what if we have $5 and 3 euro, but we wanted to we wanted to add these values together to see how much money we have in one particular currency. So sometimes we can trade our units to find a common unit. So sometimes we can trade our units for a common unit. And the reason I refer to this as a common unit, that's going to be one that they have in common. And it's also the phrasing that we're already familiar with because we talked about common denominators. I don't know why I said it that way. We talked about common denominators. And so we can take our dollars and euro. If we can do some kind of thing to them, we can make them have the same denomination. So common units could be common denominators. Common currency. And some of you in the discussion had some really cool ideas. Common types of things. So one example is if you have 5 elephants and 3 rabbits, you can't take the 5 elephants plus 3 rabbits and say that's 8 elephrabbits or relephants. That's not how that works. Language is not additive that way. But if you convert elephants and rabbits to animals, you have 5 animals plus 3 animals, you do have 8 animals. You trade your units of elephants and rabbits to a common unit, a common type of thing, which would be animals. Another one that was cool was fork and knife. 5 forks and 3 knives is 8 utensils. You change to a common currency. Just like in both of those examples, the exchange rate was 1 to 1. 1 elephant is 1 animal. In the currency example, we have $5 and 3 euro. We can write everything in terms of dollars. So let's go on to page 2. The big thing that we want to recognize when we're trying to get a common currency, one of the ways that we can get a common unit or a common currency, we can use multiplication to get a common currency. So today, that's what we want to talk about. How are we going to think about multiplication? That's what we want to think about today. How do we want to think about multiplication? One of the things that we can do with multiplication is we can use it to get a common unit. We can use multiplication to make things the same. We could use multiplication to get sameness. So we want to be able to use multiplication to get sameness. Let's look at some examples of that. On the sameness quiz, I asked you to add 5/7 and 3/11. Now, if in a vacuum, if this is just if we're out in the world and I just suddenly ask you what's 5/7 plus 3/11, first of all, you're like, oh, whoa, back off. We're not a math class. We're at the grocery store. Step 1, 6 feet apart. Step 2, don't ask me math questions here. But if in general, if you want to know what 5/7 and 3/11 is, that's a job for a machine. 5/7 plus 3/11. You can even make it show up as a fraction, 76 over 77. But that doesn't help us understand how we can use multiplication to get sameness. What we want to do is that old trick of getting a common denominator. And it's one of our favorite math tricks. We're going to multiply each of these fractions by 1, but a very specific version of 1. I'm going to turn both denominators into 77. That's going to be our common denominator. And to get to a common denominator, we use multiplication, because we can use multiplication to make things the same. I can't change the value of the fraction, so I'm going to multiply it by 1. And the same thing with the 3 over 11. I can't change the value of the fraction, so I'm going to multiply it by 1. And now they are the same. I have 55 over 77 plus 21 over 77. Now they are the same. We use multiplication to get sameness. We're using multiplication to get sameness. Any questions? So this would be the first of Leach's rules for multiplication. We can use multiplication to make things the same. We can also do this, for example, if we have $5 and €3, I can convert the euro into dollars. Yesterday I checked and the exchange rate was $1.22 per euro. So I'm going to use multiplication to get sameness. $5 plus €3, and I'm going to two of them, and I'm going to multiply by 1.22 dollars. I don't like that we write dollars before the number. Anyway, dollars per €1. So 5 plus the 3 times 1.22, that converts our euro into dollars. So now I have $5 plus, and then whatever this is going to be. Oops, no. 3 times 1.22 is 3.66. And so we have $8.66. Once again, we use multiplication to get sameness, so that now we have sameness. Any questions? So that's one way we think of, that's one rule for multiplication. One of the uses for multiplication. We use multiplication to make things the same. Any questions? All right, let's talk about part 2 of multiplication. Here's the other thing, the other way that I want to think about multiplication. Number 2 in Leach's rules for multiplication. Multiplication is repeated addition. This is more of an operational thing. Multiplication is repeated addition. Multiplication is repeated addition. So this is addition when everything is the same. Multiplication is repeated addition. That means everything is the same when we're adding things and they're all the same. So this is what I mean when repeated addition means all the things that we're adding are the same, so we'll use multiplication. So for example, if I have 5 plus 5 plus 5, I'm adding a bunch of 5s. They're all the same. It's just repeatedly adding 5. So that's 3 times 5. There are 3 5s. If I'm adding things that aren't the same, I don't get to use multiplication. The 5s are all the same, so we get to use multiplication. But if I have, say, 5 plus 6 plus 7, we don't get to use multiplication because the 5, 6, and 7 are not all the same. So we can't summarize with multiplication. The terms are all different. They don't have units. We can still add 5, 6, and 7, and we get 18, right? I think it's 18. I'm not very good at arithmetic. We can still add the numbers because there's no units. We're just adding numbers, and that's always okay. But we can't summarize it with multiplication like saying 3 times 5. Now, if we have multiple groups of things, we can summarize the multiplication where we have it. So if I have 5 plus 5 plus 5, and then 7 plus 7, I can say I have 3 5s, I have 3 5s, and I have 2 7s. So we get to summarize with multiplication. There are 3 5s and 2 7s. So I get to use multiplication on the things that are the same. So those are Leach's rules for multiplication. We can use multiplication to make things the same, to get new units, to convert from euro to dollar, or from feet to inches, or from miles to kilometers, or in America, from kilometers to miles. Because I prefer it when my numbers don't all make sense, much better. Or from kilograms to pounds. Or from elephants to animals, or from forks to utensils. And the other thing we will have for multiplication is that multiplication is repeated addition. This is what we get to, this is like a summary when all the things that we're adding are the same. Any questions? So this leads us to further questions. We've had 2 operations so far. We've talked about addition. We only add things that are the same, and when we add them, it doesn't change what they are. And we've talked about multiplication. Multiplication is repeated addition, and we can use multiplication to get sameness. So that raises a couple of questions. What about subtraction and division? What about exponents? And also, how do multiplication and addition interact with each other? So those are concerns for the future. So you can guess what we're going to be talking about on Monday in the future concerns section. What about subtraction and division? And also, how do multiplication and addition interact? Any questions? Comments? Snide remarks? Awesome. So if you haven't completed the 2 quizzes, go jump onto the Canvas and take those quizzes. They're technically due at midnight tonight, but they're available all the way to the end of the course. So I guess the due date is more like guidelines. I know we all lead busy lives and everything's kind of crazy. So get to it when you can get to it. And if you can't open it up, then just let me know and then I'll go and fix the settings. So try to get to that today so that you can work on the new one that showed up and start thinking about multiplication and combining your thinking about multiplication with your thinking about addition. Go into the discussion section, the discussion on sameness, and recognize that we're always using multiplication to get sameness if we don't have it to begin with. Every time someone posts something, you're posting things where we're trying to add things that are different, but we can get sameness and we use multiplication to do it. Now we want to add multiplication is just repeated addition. It's like a summary when we have a bunch of things that we're adding up a bunch of things that are the same. All right, so 2 quizzes, a discussion. There's a new quiz, so 3 quizzes and a discussion. So that's going to do it for today. Everybody have a nice weekend. I'll see you on Monday, and thanks for playing.
Thank you, Professor.
Thank you, Professor.